So we're going to start looking at doing standard position circle problems in radians instead of degrees. Okay, so we're going to start looking at these problems. So same thing, we're just going to go positive this way, negative this way. We want to make sure we locate the position, relate it to the angle. The position is the most important, so the different quadrants are going to be really important. Some people learn the CAST rule, or the CAST. What this means is cosine is positive in this quadrant, all are positive in this quadrant, sine is positive in this quadrant, tan is positive in this quadrant. Some people like to do that, but I think it's just easier to remember positive y, positive x, negative x, and relating sine is y, cos is x. That would be much easier to remember and more useful. Okay, so we're going to draw these in standard position. So 17 pi over 4, that means that's 8 pi over 4, 16 pi over 4, and one more pi over 4 is going to give us to that position. Okay, so there's my standard position for negative 17 pi over 4. Okay, I want a reference triangle to get my lengths, my x and y, not just lengths, but x and y position. Okay, so there is my angle, my position established using an angle. Here I can establish a position using a ratio. Now, with ratios, there's always two possibilities, but this one tells us specifically it's in quadrant 2. So sine is positive in these two quadrants because sine is y, and I can eliminate that one because it tells me it's quadrant 2. So when I draw this in, so my 5 over 3 ratio, that means that my height is 3, my radius is 5, okay, and I can work out the angle if I really wanted to. I need my calculator to do this, but I can see the positioning based on the ratio. Okay, it's 3 and 5, and if I want, I can have my x positioning using Pythagoras as -4. So this is important to understand. We can establish the position with an angle. We can establish the position with the ratio. And if we want to go between the two, we need a calculator. Unless it's a special angle, then we can kind of just see that is going to be some multiple of 45 degrees. Okay, so here's some problems then. So we want to establish the position, -1, +1. It's going to be right there. Okay, -1 to the left, +1 up. My theta is always drawn from standard position. Okay, there's my theta. So there's my position right there. That spot right there is what I'm looking for. I can calculate the radius of the circle using Pythagoras. So I'm going to get square root 2. And then I can use this triangle to establish my sine, cos, and tan. So sine theta is going to be y over radius. And we need to expand. It's not just opposite over hypotenuse anymore. Okay, because when we go into cosine, we have to remember that this adjacent is really an x position, and it makes a big difference whether they're talking -1 or +1, because +1 is going to be an angle over here. So we need to make sure that we are observing the positive and negative position of those points. And then lastly, the tan ratio here is going to be, well, that's a slope of -1, so I'm going to write -1 in there. So solving for theta, we always have to consider two possibilities. Okay, so if I undo sine, there's always two possibilities. So here's an example. Sine theta equals 1/2. So this problem, there wasn't a problem here because you were told a specific quadrant, but we could have just as easily drawn it in two different places. Well, here we don't have the luxury of knowing the quadrant. It just tells you sine theta equals 1/2. We have to consider two possibilities. It could be 1 over 2 here. It could be 1 over 2 here. Okay, it can't be down here because that would be -1. But we have two different angles here. So there's two possible solutions. So we're going to first of all start getting used to writing the notation of this. If sine theta equals 1/2, we can say the arc sine of 1/2 equals theta. Okay? We kind of need we often need a calculator for this. So if you use your calculator, you're going to get something like, I think it's 0.5 something, 5.2 or something like that. But because this is a special ratio, we can actually do this problem without a calculator. And we can say that theta 1 is pi over 6, which is approximately 0.52, if I'm not mistaken. Okay, so if you use a calculator to this, which is fine, because we do need to use a calculator to translate, but we can also be, in special cases with special ratios, we can come up with the exact value. And so there's my theta 1. That's going to be pi over 6. My theta 2, this bigger angle here, and doing a different color, this angle from here to here, well, how do I get it? Well, there's symmetry here. I can go backwards theta 1 from pi. And that's where this formula comes in. Okay, so this is where the formula comes in. So I'm going to say it's going to be, I'm going to start at pi and I'm going to take away my pi over 6. That's going to give me 5 pi over 6. And this formula is only for sine because sine is y and y has this folding symmetry across this line. Cosine has different symmetry because cosine is to do with x's. So there's this issue. We have to make sure that we remember that if we undo a ratio, we have to consider there's two possibilities. We might be able to narrow it to one given if we know the position, but if we don't know the position, we have to give both possibilities.